the last class we discussed basic functional block diagram of the PLC, right? We have seen different functional units in the PLC. One is the CPU, and another one is the input module. Third one is the output module, along with the power supply and program modules are other units in the PLC basic block diagram. And then we discussed what is the function of each one. Now, in today's class, we are going to discuss a little bit more the electronic circuitry present in the input and output module, right? So we know input module is used to condition the signal before giving input to the CPU by taking the different parameter values from the field, right? So, see, the IO module is taking input values from the different sensors and transducers from the field area in industry or in any application or in any process, and conditioning inside and giving output signal to the CPU, right, which is compatible to CPU, right? In the similar way, output module is going to be do same opposite operation, right, by taking output signal from the CPU as an input, conditioning inside, and controlling the output device, which are going to be connected to the output module. So normally in the last class also we discussed what are the different devices we are going to connect to input module as well as output module, right? So now we are in this class going to be discuss internal functional electronic circuitry in input module as well as output module, right? So normally these IO module interfacing circuit we are going to discuss. In this IO module interfacing circuits, what is we have input module as well as output module. Input module we have as well as output module we have. We have an input module and output module. Input module, internal electronic circuitry we are going to discuss in this class, as well as output module, internal electronic circuitry we are going to be discussed. Overall, what is the network we have in that particular module to do particular required task by the input module as well as output module, right? So this is hardware module. This is also hardware module. For example, this is the input module. For example, this is the input module, right? This one is the output module. So it is some electronic circuitry there internally, right? To condition the signal getting from the field, sensors or transducers, right? As well as it is giving input to the CPU. From the CPU, after doing something inside CPU, right? It is giving output signal as an input to the output module, and it is outing the signal to control the loads, right? For example, here actuators to control the actuators, right? So now it's giving some signals, conditioning inside the IO module, input module, and doing something in the CPU based on the program you written on the input data, and it is outing the data that is acting like input to the output module, right? Output module which is going to be connected with actuators, right? So this signal outing from the output module is used to control the actuators, right? So this is simple thing. Now how it is conditioning? What are the different possible input signals getting from the field to the input device, right? Then how it is going to be conditioning input signal getting from the different sensors before giving to the CPU. What is the electronic network present in this particular input module? We need to discuss in this particular IO module interfacing circuits concept, right? As well as after doing some operation on the given input data in the CPU based on the program written, right? So we are going to get some output. That output is going to be given as an input to the output module. In output module, we have some circuitry, right, to control the connected device to the output module. That is output device are actuators, right? So now simply what are the expected signals coming as an input to the input module? In the previous class also we discussed different sensors and transducers are taking signal from the field which are going to be levels of different voltage levels. Electrical signals are coming as input to the input modules from the different sensors and transducers from the different field points in the industry. Alright. So those may be, these sensors may be, some are 24 volts DC, right? Some are 120 volts AC, right? Some are 120 volts DC signal, right? Volts DC signal, right? Some are like that, 230 volts AC, 230 volts DC also. Like different devices are going to be get signals with different voltage levels. That may be AC signal or DC signal. But we need to condition this particular signal before giving to the CPU. Why? Because this CPU can able to read 5 volts DC or 5 volts 0 volts DC signal. 0 volts DC or 5 volts DC or in between any voltage level between 0 volts and 5 volts DC only, it can take as input to the CPU before doing some operation on the given. So based on the program, it is going to be perform some operation by taking this input signal, that is DC signal. Right? In the similar way, after doing something operation in the CPU, this is giving input signal once again to the output module, whether 5 volts DC if it is on state, 0 volts DC if it is off state, right? But this 5 volts and 0 volts DC which are going to be considered as an input to the output module is not enough to on and off or turning on and off these actuators which are going to be connected to the output module. Normally, what are the actuators we are going to connect in industry? In industry, we are going to connect some solenoid valves, motors, heaters, and all the things we already discussed. Maximum devices are going to be controlled with 230 volts DC and higher voltage values. AC signal, that is also right. That is going to be on and off. These signal getting out from the CPU, 0 volts DC or 5 volts DC is not enough to control that particular actuators which are going to be work with higher voltages, right? So to control those higher voltages, this signal getting out from the CPU as an input to the output module is used to turning on and off these loads, right? If it is 0 volts, it is going to be turn on. If it is 5 volts, turn on. Like that, it's need to be controlled. Output devices are going to be connected to the output module, right? To make this, we need some electronic circuitry inside the output module, right? So to design some circuitry, before designing some circuitry inside this particular input module or output module, what are the things we keep into the mind? First thing. Then the second point is after design, what this electronic circuitry contain different circuit arrangement, how it is circuit arrangement is there, how it is going to be function. That's what we need to discuss, right? So now, first thing, normally one by one we will see how input module is going to be, hardware input module is going to be present, right? So what is the things we need to keep into the mind before designing inside circuitry, or otherwise by looking into the internal circuitry, how it is going to be a function, we need to discuss, right? So now first we will see the input module. Then we will see the output module. Alright. First we will see the input module. So it is giving 5 volts DC or 5 volts AC to the CPU. Right. So what are the points we need to keep into the mind before looking into this particular, what is the electronic circuitry present in the input module? First point is what? It may get the different levels of electrical signals as input, right? We need to condition, we need to design circuitry in input module in such a manner that it should be able to optimize, or it should be able to condition various signals to signal which is compatible signal to the CPU. right? So for example, for example 230 volts DC, 230 volt AC is getting as an input to the say IO input module from the any sensor. So same voltage we cannot pass through the CPU. So we need to condition that 230 volts to the 5 volts like this. Alright. So we need to rectify, step down, then we need to give as an input to the CPU module. Right. In the similar way, something device sensor is giving to 24 volt DC. We need to step down that voltage. Then that is need to be given as an input to the CPU. For example, input is 0 volts. 0 volts is going to give as an input to the CPU. That means what? We need some conditioning circuit for the different input electrical signals need to be conditioned and then it has to give to the CPU. That is the first point. Second point is what? This is different electrical signals are coming. This first point is what? We need to first point is what? First point we need to consider is this should be acquainted with different electrical signals. That means something internal circuitry should be designed in such a manner that so by may expect different voltage signals as an input, and it should be able to condition that signals and suitable signal you need to pass through the CPU. Right? That is the first point. That means signal conditioning is required before giving as input to the CPU. Right? Second thing is these are different electrical signals with somewhat AC and DC. Right? And from the field, the signals coming as an input to the input module. So always from the field, some electrical signals at the different levels as a coming to the input module means there is always some fluctuations are there in the input signals. These high levels of voltages fluctuations at the input level should not be damage the CPU device, which is going to be work with 5 volts DC and 0 volts in between 0 volts and 5 volts. That means it is work with low voltages. These fluctuations are very wide in signals getting from the field sensor to the input module. So this need to be isolated. This should be isolated. CPU should be isolated from the fluctuation in the input signals, right? So isolation circuit should be there. Isolation should be do between the CPU and input signals to minimize or to avoid the effect of fluctuations in the input signals, right? These are the two main things, right? So third thing is input module is always taking signals from the field sensors, right? So fourth one, it should be connected with some power supply and ground, right? Input module should be connected with some power supply ground, right? By keeping these particular three points, it is going to be take values from the input values from the different sensors and actuators, right? So by keeping these three things, we need to design internal electronic circuitry of the input module. Otherwise, by looking into this particular internal circuitry, we are going to be understand what is going to be performed by the IO module, right? So that's what. So before looking into this particular internal functional electronic circuitry of the input module, I want to show you that how input modules may present in the industry atmosphere. Right? Normally input modules are like this. This is, for example, input module means, right? Input module means it has some power supply terminal. This is power supply terminal. It may be any volts depending upon the module. For example, 24 volts DC, right? So power supply. You can say that this is the line voltage. Right? So another terminal is ground terminal. This one is the ground terminal, right? So in every input module in the industry, has some power supply terminal. It may be any voltage power supply terminal, and another one is the ground terminal. You can say that this is the line voltage, right? Along with these two terminals, it has a number of terminals. This number of terminals which are going to be connected with input sensors, or transducer, which are going to be present in the different locations in the industry, right? These number of terminals for input module is going to be vary from one make to another make, or depending upon the requirement, you can go for the 4 terminal IO input module, or 8 terminal input module, or 16 terminal input module, or 32 or 64 terminals, right? So these are different terminals, different number of terminal IO input modules are there. These are maybe 4 terminal input module, 6 terminal input module, or 8, 12, 16, or 32 terminal input modules are there. Right? So that is depending upon the requirement, right? Some modules like both input module and output module are combined on the same thing, right? So that may be equal number of input and output terminals may be present, or different number of terminals may be present, right? So for example, if you consider same module, IO module, means input and output terminals are going to present in the same module. In that case, maybe input module 8 terminal may be there. In the same module, 4 terminal output, 4 out allotted for the output also. That means 4 output terminals, right? So equal or unequal, or otherwise separate input module and separate output module. If you input module, if you consider depending upon your application, you may go for 4 terminal or 8 terminal or 16 terminal, like that. In the similar way, output terminal also you can consider different number of terminals depending upon the application. Why I am going to stress here is like that, means some process, to control some process, may read only 4 input signals from the different field devices. In that case, 4 terminal input module is enough. If you want to control only 4 output device actuators, 4 terminal output module is enough for that particular application, right? If you go for high-end application, it may need to read 16 inputs from the 16 different field devices. In that case, you need to go for the 16 terminal input module, as well as outputs also. Depending upon the number of outputs, you need to go for the number of output terminal output module, right? So you may get doubt. If more than number of input terminals or input signals or output signals, if you want to read from the field in such application, then you need to go for another input module as well as another output module, right? You can add, for example, 64 inputs. If you want to take 16 terminal, 4 IO input module, you can go and you can place in the one by one in the RAM, right? Otherwise, 32 input terminal IO module and 32 input IO module you can place together for such application, right? So that is the use of this particular. That is the way this input module or an output module are going to be get in the market to utilize in the process, right? And another thing is this power supply. This input module may be AC module or DC module, right? AC module or DC module, right? So depending upon the supply you are applying here, if you apply DC supply, this is going to become the DC input module. If you apply AC supply, line voltage is AC, this is going to be AC input module, right? So if you apply DC, it's not going to be DC module. If it is DC module, you need to apply DC supply, right? If it is AC module, you need to apply AC supply, right? So my intention is that you can go depending upon the application to purchase AC and DC separately, right? So that's what this is the use of input module. This is the way input module is going to be present, right? In the similar way, output module also. If this is the input module, right? Output module also. Normally, this is also have some line voltage, power supply terminal, and ground terminal. ground terminal. In between these terminals these terminals are there to connect to the output device, that is actuator. So these number of terminals are going to be vary as like input module. Depending upon the application, you can go for the 4 terminal or 8 terminal or 32 terminal output module. Otherwise, both are integrated on the same module. One module is the IO module is also there. In the IO module, 8 terminals are allotted for the input and 8 terminals are allotted for the output. Right. So now next step is what is the internal electronic circuitry of the particular input module and how it is going to be work to fulfill these 3 points. One is it should be take input values from the different sensors. Second thing is it needs to be isolate electron fluctuations getting from the input values to the CPU. Right. Third thing is it may get different values of input values, different values like different levels of values that should be conditioned to give as an input to the CPU. Right. So by keeping into these 3 mind, we'll see what is the internal electronic circuit may be present, or by looking into the internal electronic circuitry, you can justify these 3 things. Right. So we'll see now input module, transducer. Right. This is going to be switch on and switch off depending upon the signal getting from the field device. Right. So this is going to give input signal now. Right. This is going to be connected to the line voltage. Line voltage, for example, 230 volts AC. 230 volts AC. It is given as an input signal, right? Input signal, right? Input. This may be a terminal from the terminal 1. Terminal 1. So what I am going to be draw is only internal circuitry for the only one terminal, right? So if it is IO device is there, right? It may contain number of terminals. For example, 8 terminals are there, right? This is the first terminal. This one is the 8th terminal, right? So I am going to be discuss only electronic circuitry. That means circuit arrangement of only one terminal. Terminal 1. This is same for remaining all terminals. One terminal you discuss, the remaining is all same, right? For 8 terminals, 8 internal circuitries are developed like this, right? So this is line voltage. Now this is going to be connected with rectifier circuit, bridge rectifier, right? So here bridge rectifier. This is going to get as an input to the by this time it is going to get some DC voltage, right? This is the rectifier, right? AC voltage is going to be rectified, right? So here you are going to get some voltage, right? Here J0 diode we need to connect in reverse bias direction. It is used to this J0 diode is used to what condition? Voltage conditioning purpose, right? Then this voltage, whatever you are going to get, is passed through photodiode, right? And it is going to pick up with phototransistor, and this signal is going to give as a output value or output voltage to the CPU, right? This is going to become signal isolation circuit. Right? So overall, so once again we'll see whatever the signal getting from the terminal 1, right? If it is, this switch is on, means this voltage is going to give, right? For example, this is power supply is 230 volts AC in the input module, that's AC module, right? If whenever pressure switch is given some value, then what will happen? This is going to be step down here in this module. Step down will take place before rectifying this particular value. Step down transformer is there, right? So then it is giving value to the bridge rectifier. Then you will get some voltage output, 9 volts are like that. Then basic here the Jenner diode with breakdown is what is 5 volts. So this circuitry is going to be act like a voltage regulator, 5 volts. We are going to get the 5 volts output DC voltage. So here this one is a photodiode. It is 5 volts DC is converted into the light signal. This light signal is going to pick up the phototransistor. This is the photodiode, right? This one is the phototransistor, right? So this is giving this light energy is converted into electrical energy. Once again, that is 5 volts. Equivalent 5 volts is going to be DC is going to be generated. That is going to give as an input to the CPU. For example, if it is switch is on like this, if it is 230 volts AC IO module. For example, this is the power supply. Here is 24 volts AC signal. This one is the 24 volts. 24 volts AC signal. Right? Here transformer is going to be step down value and is giving to the transformer is not required normally, but for 24 volts AC, right? Directly you can rectify and you can regulate that particular value, right? If it is 230 volts AC, here step down transformer is going to be used, right? Transformer is going to be used, and then step down AC voltage act like input to the bridge rectifier. Then you are going to get some DC voltage. So here by using voltage regulator, Jenner diode is voltage regulator, and finally you are regulating to the 5 volts DC. That is for isolation circuitry. We are using combination of photodiode and phototransistor. Same voltage is generating light. Light is converted into the voltage. That voltage is going to act like a CPU. Right? So this may be, any switch may be from the field. It's going to be switching. If it is high, it is going to be on. If it is low, it is going to be open. If it is a line on, this voltage is acting like input to this circuitry. Finally, it's given 5 volts DC. That means it is on 5 volts DC. Taking this input data by the CPU, it will do something and it operates. Next level is the output module, right, which is going to be connected. Right? If it is not on, input signal is not there, switch is off position, there is no voltage. 0 volts is going to act like input to the CPU. Right? So 3 things is going to be happen. Three things you need to consider. One is it has to take input value from the different sensor. So satisfied. Second thing is this value may be any values. Different values are there. So based on that, to condition that different values to the suitable value for further process, right? We need this particular rectifier circuit. Right? If it is DC voltage, step down operation, that some chopper or something is enough, right? So step down that particular voltage and regulate with Jenner diode using this particular combination isolation. Why? Third point is what? isolation. That means if there is any fluctuations in the input voltage, that should not be damage the electronic circuitry. So that is the reason isolation is going to be performed by using this particular isolation circuit, by using this particular combination of photodiode and phototransistor, right? So this is the internal electronic circuitry of the IO module. That is also for the, this is all circuitry for the only one terminal, right? So remaining terminals, same circuit are going to be used. That means this, like this circuitry for the terminal 1, like this circuitry for the terminal 2, like that up to 8 terminal. If it is the 8 terminal input module, right? So this is about the input module, internal functional electronic circuitry, right? So three things. Finally, objective is that different signals may get from the different sensors. Those signals we need to be conditioned, and then output should be 5 volts DC or 0 volts DC. Second thing is different fluctuation, electrical fluctuation may get from the field. That should not damage the electronic device, that is CPU. That for that isolation circuit is there, right? Third thing is, depending upon the number of input sensors, we need to consider IO mode, input module. If it's 8 sensors are there, 8 terminal or 16 input sensors are there, 16 terminal input module we need to consider. That means what? Input terminal is taking values from the different field devices, which is going to be connected with different sensors and transducers from the field. That is about the input module and input module internal circuitry, as well as what are the different input modules may get in the market, right? So that is about the input module. Now we will look into the output module, internal electronic circuitry, right? Now output module, internal circuit, right? So output module, for example, if you consider output module, the similar way, output module, for example, if you consider 8 terminal output module, what is there? This is the ground terminal, this one is the power supply terminal. For example, always output devices which are going to be connected to the output module work with 230 volts, here 230 volts AC, right? So remaining all terminals are going to be connected with different actuators, right? Different actuators. It may be connected with some heater, or it may be connected with some wall, or it may be connected with some lights, right? So this is going to be connected. For example, this fan and light and all the things we can connect, right? So now what? You will get something from the inputs module, that is previously we have seen 5 volts DC or 0 volts DC signal to the CPU, right? You return some program inside the CPU like that. If 5 volts come on the something device, for example, light you connected to the output module, right? So this is need to be on. If, for example, 0 volts will come as a input to the CPU, based on your program written in CPU, it should off the light. Right? That means what? CPU should be control output device based on the output signal coming from the input module as input to the CPU. That means what? CPU needs to be control this output actuators which are connected to the output module based on this particular signal getting from the output of the input module, right? So I return based on the program along with input data. Based on the program, it is going to be on and off the loads, right? So normally what these loads, whatever which are going to be connected to this output module always with higher voltages, whether whatever the things we consider in this room also, fan, light or AC, all are work with higher voltage, 230 volts AC, right? This higher voltage should not damage this CPU. That means isolation circuit is required. First thing, right? And second thing is what? This 5 volts or 0 volts able to send out by the CPU. CPU is also able to out 5 volts DC or 0 volts DC after doing some operation in the CPU. Based on the input data, it is doing something operation based on the program you written, right? Then result may 5 volts DC or 0 volts DC as an output, right? But these voltage levels are not enough to turn on and off that means to operate this particular loads. These voltage levels, whatever you are getting out from the CPU, is only able to on and off the loads. It is just switching on and off external loads. Somewhat based on the output from the CPU, it can able to only switching on and off the power which is going to give as input to the loads, right? So that is the thing is going to be happen for every terminal, same operation, right? We'll see now internal circuitry of the output module, right? So what is the signal you are going to get from the CPU? From the CPU, what is the output signal we expected, right? After doing some operation in the CPU, it may 5 volts DC or 0 volts DC as an input to the as an output from the CPU to the input module. This is input module to this particular input module. In this input module, we have to design circuitry in such a manner that it should be isolated from the fluctuations getting from the higher voltage devices which are present in the output field, isolate, as well as this signal 0 volts or 5 volts coming out from the CPU. We should able to control output actuators. That means it able to turning on and off the output devices. Like that, it's need to be designed. Right here, reverse operation. Same thing. Reverse operation. It's going to be. This is the photodiode. It can able to convert this DC voltage, that means electrical signal, to the light signal. Then it is going to be received by the phototransistor. This one is the phototransistor. This combination is going to be used as an isolation circuit, right? So this signal coming out from this isolation circuit, that means whatever the signal out from the phototransistor, maybe this one is the 5 volts DC, is going to be used as a trigger circuit to the triad. This triad is going to be act like a switch. Gate pulse. This is acting like a switch for the output loads which are going to be connected. So load is connected with some 230 volts AC. Alright. So it's overall circuitry. If you see this particular circuitry, right? This is acting like a triggering circuit. Triggering circuit for this particular load, right? So once again, we'll see now. What is the signal after doing some operation on the input data based on the program, right? This signal may use it to turn on and off the load, right? So now this 5 volts or 0 volts is directly not able to control this load. This load is going to be controlled with higher voltages, 230 volts AC. But you can on and off this particular load by controlling this particular switch. This is the triad. This triad is going to be triggered, or that means you can on and off this particular switching on and off triad to get the supply to the load 230 volts, or you can stop also, right? So see here, this is isolation. 5 volts, for example, it want to on the load, for example, then it's giving 5 volts DC. This 5 volts DC is signal is converted into the light signal by the photodiode. This is going to pick up by the phototransistor. Same 5 volts DC signal is going to get. That is going to be act like a input pulse signal to the triad. Right. This is going to be on this particular load. That means it's going to be close the circuitry to on the load. Right. For example, if CPU want to off the load, for example, load is the fan. If you want to off the load, it is going to be 0 volts as a DC as input to the photodetector. Light is not going to be out from the photodetector. This here is going to be get the 0 volts DC. This 0 volts DC means it is not going to be give any trigger pulse. Then what will happen? Its triac is in the open condition. Right. This circuit is open condition. Load is going to be off. Right. So through two things is what? This higher voltage should not damage the CPU. For that isolation circuit is required. This low voltage is not able to control the loads. It is only used to break the circuit or to on the circuit. That leads to be on the on and off the load. Right. So this triggering circuit or this switching element is there. This is a triad. This triad switching element we are going to use for to control the output if output loads are working with AC signal. Right. For example, if you want to control something device which is going to connect as the output working with DC, then you need to go for the here switching device is the transistor. That is also for the lower level voltages. Right. And another one, you all know that here we can use this switching element relay. Relay also you can use as a switching element, which is used for the both AC switching as well as DC switching. For AC load or for controlling DC loads also, you can use relay. But the switching action is slow in the relay. Right? That is the reason you go for the DC switching, you go for the transistor. And for AC switching, you go for the triad. Right? This is the internal circuitry, electronic circuitry of the output module. Right? So this is the way input and output modules are going to be internal circuitry is going to be present. This internal circuitry is used to condition the input signal, isolate the fluctuations, damage towards the CPU. Right? So input module is always used to connect the field device to the PLC, and output module is always used to connect to the output devices which are actuators to the PLC. Right? So this is about the input and output module interfacing circuitry. Right? Thank you. In the next class, we will see the processor. What are the different processors are there, and how functionality and performance of the PLC is going to be vary with the processor. Little bit more. Previously we discussed about the processor, the slightly what is the use of processor. But now we will look into the little bit more insight to the processor contribution in the PLC in the next class. Thank you.